Now we're going to talk about rules for working with square roots. The first thing we need to understand is notation. So if I have something beside a square root of something else, that there's understood multiplication happening between those two things. So m times the square root of x is the same as m times the square root of x. In our first example here, we have 2 times the square root of 9. So that equals 2 times, well, what's the square root of 9? 3? Yep. So what does 2 times 3 equal? 6. Easy enough. In the next example, we have 3 times the square root of 5. What do you think that will equal? Well, is 5 a perfect square? Nope, it's not a perfect square. There's no whole number times itself that will equal 5. So therefore, we cannot take the square root of it, so we're just going to leave it. And our final answer will be 3 times the square root of 5. The second notation I want to talk about is having an opposite symbol in front of your square root symbol. All it means is opposite. So you take the square root of the number and then put a negative in front of it, because when you take the square root of a number, it will always be positive. The number that you're taking the square root of will always be positive. So your answer will always be positive. Therefore, if you're finding the opposite, it becomes negative. So the opposite of the square root of 144 equals negative 12, since the square root of 144 is 12. The next rule is what happens when you multiply two different square roots. So if I multiply the square root of something times the square root of something else, whether they're the same or different, it doesn't matter. So this could be the square root of x times the square root of x, or the square root of x times the square root of y. Either way, it's the same thing as having them both underneath the square root symbol multiplying. In other words, according to order of operations, here on the left hand side, for square root of x times square root of y, we would take the square root first. Then we would multiply. On the other side, we would multiply first, and then we would take the square root. So let's look at some examples. So first we have the square root of 4 times the square root of 9. Well, the square root of 4 is 2 times the square root of 9 is 3. So notice how I took the square root first before I multiplied. Now I'm going to multiply. 2 times 3 is 6. Versus the next problem. In this problem, the notation means to go ahead and multiply before you take the square root. So my order of operations based on this notation means multiply 4 times 9 first, and we get 36. So the square root of 36 is 6. So this notation is telling us it doesn't matter if you take the square root first or if you multiply first. Either way, you're going to get the same answer if you're multiplying. And this also applies to division as well. So the square root of 25 is what? 5. Square root of 4 is what? 2. So what do we get? 10. 5 times 2 is 10. So what do you think we're going to get for the square root of 25 times 4? We should also get 10, right? So what's 25 times 4? 100. So we're going to take the square root of 100. And what's the square root of 100? 10. Indeed, it worked. Next, we have the square root of 16 times the square root of 4. So which do we do first here? We should take the square root first here, right? What's the square root of 16? 4. What's the square root of 4? 2. Good. What's 4 times 2? 8. Now if we multiply 16 times 4 first, do you know what that equals? It equals 64. What's the square root of 64? 8. Now this next problem is a great example of when we use this property. So here we have the square root of 2 times the square root of 8. Well, what's the square root of 2? It's just the square root of 2, right? You can't take the square root of it. It's not a perfect square. There's no whole number times itself that equals 2. What about the square root of 8? Same thing. You cannot take the square root of 8 because there's no whole number times itself that equals 8. But we can multiply these, since we know that that's the same thing as this, where we multiply under the square root first. We can end up with the square root of 16, which we can take the square root of, which is 4. So now you can see where it comes in handy to understand that you can multiply first or you can take the square root first, whichever is easier. And it also, like in this previous problem that I'm rewriting up here, maybe you don't know what 16 times 4 is. That's okay. you can take the square root of 16 and square root of 4 and then multiply. Now addition is a different case. With addition, we cannot take the square root separately, then add and have that equal adding and then taking the square root. They will not equal the same thing, okay? So let's look at some examples. What's the square root of 9? 3. Square root of 25? 5. What's 3 plus 5? 8. Okay? So now let's look at the next example. 9 plus 25, what does that equal? 34. So what's the square root of 34? Well, it's certainly not 8, right? Square root of 64 is 8. So you just have to leave it because square root of 34 is not a perfect square, so you just have to leave it as the square root of 34. Now it would take the square root of 64 to give us 8, right? So obviously the second problem here is much smaller than this first problem here. It has a much smaller value. All right, let's look at the next problem. Square root of 4 is 2. What's the square root of 64? 8. What's 2 plus 8? 10. So now in the next problem we have to add first before you can take the square root. So what's 4 plus 64? So that's the square root of 68, right? What's the square root of 68? Well, we don't know. It is not a perfect square, so we cannot take the square root of it. But we do know that the square root of 100 is 10. So we know that 10 is actually a lot bigger than the square root of 68. We have a few more rules. So the next part is the square root of x squared equals x. And the next example, or the next property we have here, the square root of x squared equals x. So let's think that through. It will make a lot of sense to you. So think about what x squared is. X squared means x times x, right? So if we think about our square, x squared is the area, and x must be the lengths of the sides. So the square root is always the length of one side, so our square root is x, and then the perfect square is the area in the middle, which is x squared. So the square root of x squared is always x. Another way to remember it, and this is really the most important way, is that a square and a square root are inverse operations. They cancel each other out. So if you want to get rid of something squared, you take the square root of it, and it comes back to being just that base. So let's look at the square root of 4 squared as an example. The square root of 4 squared means the square root of 4 times 4. Well, the square root of 4 times 4 is the same thing as the square root of 16, which equals 4. Again, if we have that picture of a square, our area is going to be 4 squared, which is 16. Therefore, the length of each side must be 4. So the square root is 4 and the area is 16. Or the easy way to remember it is square roots and squares, there's an understood 2 here, cancel each other, and you're left with your base of 4. We have another property that is very similar. The only reason we have it is to deal with order of operations. So the square root, this is basically saying the square root of x raised to the second power. So the second power is outside of your square root symbol here. It's still going to equal that base of x. You still have a square and a square root canceling each other, leaving you with the base. So let's look at an example again to show you the difference between the two. So the square root of 4 squared means the square root of 4 multiplied twice. So that's slightly different than our previous example. And we know that this is 2 times 2, which equals 4. So we're just addressing the two properties. It works for both of these. Both of these properties end up working for the same reason, that the square root of x times the square root of y equals the square root of x times y. It doesn't matter if you take the square root first and then multiply, or if you multiply and then take the square root, you'll end up with the base whenever you have the square root of anything squared. Those squares will cancel each other and you're left with the base. Scroll to the next page and I'd like you to practice these properties that we've just learned with these problems. Pause the video and come back and see how you did. The first problem is 64 because you end up with 6 times 4 after you take the square root. The second problem is 7 times 2 after you take the square roots, and you end up with 14. Now you could have multiplied 49 times 4 first if you wanted to, but I think this is a little easier. In the next problem, you have the square root of 144 times 64. Well, I don't know about you, but that math is going to take me a couple minutes, so I'd rather just take the square root of 144 and the square root of 64 separately to get 12 times 8, which equals 96. In the next problem, you have to add first. You don't have a choice. 100 plus 81 is 181. That's not a perfect square, so your answer is the square root of 181. The next problem, the square and the square root cancel, and you're left with the base of 9. And the next problem, the square and the square root cancel, and you're left with a base of 121.